So we would be starting the building of the circuit. From the circuit diagram you can see up here, we have our battery of the circuit, and this is our battery we'll be using. The two terminals of the battery, the red represents the positive, while the black represents the negative or the ground. And we have our resistor here. These are samples of resistor. These are resistor looks. So these are samples of resistor with the required colors on the body. You can see the bands of colors on the body. So these are the resistors, several resistors, though we are going to use just one, but these are resistors. And this is the LED. This is just the light emitting diode. So whenever current flows through it, it emits light. And so the next thing for us to do now is to connect this circuit. Remember, in one of my previous videos I tried explaining how the breadboard works, and I said this particular roll of the breadboard is connected underground. So at the back here there's a connection that has been made under, such that all these holes are connected horizontally. All these are connected horizontally, but note that there is a bridge here that needs to be that is open. So to make the connection complete, you have to loop this point to this point with a pair of wire, or with a piece of wire rather. So you have to loop this place to this place with a piece of wire, and also you have to loop this place to this place with a piece of wire to continue the line of connection. The same thing applies to these two horizontal lines below here. So you have to loop this place to continue the connection if there's need for that. That's if you want to use the whole board, but if you just want to use this section, you don't need all those. Now, so this top and this bottom are connected horizontally. These four lines are connected horizontally, and most times I prefer to use them for my power rail. So most times I like connecting my batteries to these points. But this other part, this part labeled A to E, they are all connected vertically. As you can see, all these are connected vertically from these points to the end. There's a bridge, there's a gap here in the middle. As time goes on, you understand why that gap is for. Is there, is placed there, and the reason why we need such to be useful when we start working with ICs. But just note that these parts are connected vertically, and from F to J also, they're also connected vertically. So you are at liberty to use any part of the breadboard for your design. There's no strict hole for a particular design. Just know how to make your connections, and this is just your board for that. So we'll begin the circuit from our circuit diagram up here. You can see we have our battery, we have a resistor, and we have an LED. I usually love to connect other parts of the circuit first before I connect the power. So that's just the practice, my own practice. I prefer to connect other parts of the circuit, be sure the connections are well connected before I connect power. So isolating the power, I'll have to connect the resistor and the LEDs together. You will see that one end of the resistor goes to power, the other end goes to the anode of the diode, that's the LED. Now looking at the LED, you will notice that the LED has two terminals, and if you look very closely, one terminal is longer than the other one. So the longer terminal, this is the anode, while the shorter terminal is the cathode. So you connect this shorter terminal is like the negative, while this longer one is the positive. So this long one is the anode, the short one is the cathode. So that should guide us. So anytime you look at a diode, LED, light emitting diode, you can easily know which terminal represents what based on the length of the pins or the terminals itself. So now I'll be connecting my LED, as you can see in the circuit, to this second part of the resistor. In my design, in the circuit here, we are using a resistor of 330 ohms, but I'm working with what I have here. I think I have a green LED, and I'll be making use of 470 ohms resistor. And you can look at the body very well. The colors on the body, it's yellow, violet, brown. Then the last band here is gold. That's the tolerance. I just hope you were able to see that. So I'll be connecting one end of the resistor to the anode of the LED. So this is the anode of the LED, the long part. So I'll just dip that into any hole of my choice. So I'll place the LED into any hole of my choice and make sure the connection is tight. So, so this is my anode and this is my cathode. So the anode, one end of the cathode is connected to one end of the resistor. I said it that these lines are connected horizontally and vertically. So anything I place in this line is already connected. So once I put this resistor in any of these holes on that particular line, I've already made a connection. So this is already connected. This line, this pin and this pin is connected. And one of the best ways I check for the connect to check the connection to be sure they are well connected is I use my meter. This is my multimeter. Then there's something we call continuity test with the meter. It's used to check if a connection is continue, or if there's a continuity rather on your connection to be sure there is no open circuit along the way. There's no breakage in the continuity. So you use your meter to check that. I do that most of the time. So you set it to continuity test. Every meter has its own settings for that. You just adjust your knob to the right place. So you put the two probes together, it makes a sound. It tells just to tell you that okay, those 2 points are connected. So now I'm going to check if this resistor pin and this LED pin are connected. If they are connected, there will be a sound on my meter. So with the sound you are hearing, it tells you that the connection was perfectly done. So I may not do this again, but just to show us that you can check for continuity with your meter. So I continue with the design. The next thing to do is to connect the cathode of the LED to the negative rail. For this design, I'm using this place as my positive rail. I'm using this place as my negative rail. So to connect the cathode, I'll just put a wire at one of the ends. That's the cathode line, the line for the cathode. You can see the same line where the cathode is. Same line, I'll put a wire there and connect it to ground. I want to use this particular line for my ground, for my negative terminal of the battery. So I just connect it to the ground. Then the last connection is to connect the second part of the resistor up here to the positive terminal of the battery. So this is my, I want to use, remember I said I'll be using this place as my positive and this place as my negative. So the positive rail, which is this, I told you that this is connected horizontally. So the positive rail is where I'll connect my second pin of my resistor. So I can just decide to use any of the holes there. Any of the holes there will give me my positive rail. Any of the holes here is the negative rail. Remember, I connected this to my cathode of the LED. And the last thing I need to do is just to connect my battery. So I just simply put my negative wire into the negative rail and I put my positive wire into the positive rail. So you can see my LED is on. So the LED comes on, gets lit on, and that's just how to build this circuit. So we've succeeded in lighting up an LED. You can read you can use your meter to check the voltage drops across all the components to be sure if it tallies with your calculation. Remember in the calculation we did, we use an amber colored LED, but here I am using a green LED, and we used a 350 ohms resistor in our calculation, but here I'm using a 470 ohm resistor because of I'm working with what I have here at the moment. So let's quickly measure the DC voltage. On your meter, you just adjust your knob to DC voltage. So anywhere you see V with a straight line, that's your DC voltage. If you see V with, okay, let me see if you are seeing my meter. If you see V with an alternating symbol, that's alternating voltage. When you see V with a straight line, that's direct voltage, and it's the direct voltage you want to read. So you set your meter to that. Okay, let me see. I just hope you can see my meter. So you take the two probes of your meter and you connect them across your LED. So let me connect them across my LED. So connecting it across my LED, I can see a voltage of 2.87 volts. So there was a voltage drop across this LED, 2.87 volts. Very much similar to what we saw on the chart. This is 2.87 volts. And if the battery were to be a 9-volt battery and 2.87 volts drops across the LED, the remaining voltage from the battery should be across the resistor. So let's check across the resistor. We have 6.2. So once you sum up 6.2 and 2.8, you should be getting the value of the voltage of the battery. Let me check the voltage of the battery. And the voltage of the battery is 9.8. So when you sum it up, you'll be getting approximately the value of the battery. If there are little changes, it's due to experimental errors, some conditions, maybe um, based on where I am performing the experiment, it may affect the readings one way or the other. But I'm sure you understand the whole concept. So this is just the way to connect electric circuits using the breadboard, and we've successfully turned on an LED with a 9-volt battery. So this is the circuit. You can take a look at it again. We had our battery, our um, resistor, and our LED. So that will be all for this lecture. Thank you for taking time to go through the lecture. Subscribe to this channel, like the video, share with your friends, click on the bell notification to get notified whenever a new video is dropped. Thank you.